Hello and welcome to notes number 2 in our scientific notation unit. And this notes are on rewriting numbers in scientific notation. For these notes today, you're going to need a calculator to do some of these operations. So if you don't have one with you, please press pause, go grab a calculator, and then come on back. Okay, so for these first exercises, it just says to use a calculator to find the products or the quotients. So type them right into your calculator, write down each answer, and as you do them, I want you to see if you can find a pattern or make predictions about what you think each answer will be. So press pause now and use your calculator to fill in the next few answers. Okay, now that you've answered these first 8 questions, you can see that when you multiply by 10, the number's getting bigger. And when you're dividing by a power of 10, the number's getting smaller. And you're basically the decimal point, the shortcut way of thinking about it is that the decimal point is moving to the right when you're multiplying. The same number of place values as the number of zeros in the number that you're multiplying by. And you can see this happens over and over again in each one of these problems. When you divide by a power of 10, it moves to the left. Like in number 6, the decimal was behind the 2, but you're dividing by 1,000. So it ended up moving 1, 2, 3 place values to the left. Okay, the same thing in number 8. You're dividing by 1,000. So the decimal started behind the 7, and it moves 1, 2, 3 place values to the left. So when you see the question below, what you notice when you multiply or divide by a power of 10, you see that when you multiply by a power of 10, the decimal moves to the right, the same number of places as the number of zeros. When you divide by a power of 10, the decimal moves to the left. Okay, so hopefully this pattern can help us rewrite numbers correctly in scientific notation. So let's take a look at the next examples. It says rewrite each number below, so it's in scientific notation. Because right now they're in standard form. So we're going to rewrite them in scientific notation. So for example, the first one, number 9, we know that we have to put the decimal after the first non-zero digit. So I'm going to write 1.85 times 10. And now I see this is a very, very large number, so the exponent is going to be positive. And I count how many place values I needed to move to get it to that spot. So when I count that, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It would have been 11 place values, so it's 1.85 times 10 to the 11th power. Okay. However, when we try something like number 11, that's a number much, much smaller than 1. But again, we're going to put the decimal after the first non-zero digit. So it's going to go right after the 8. The coefficient has to be greater than or equal to 1, less than 10, times 10. And again, I'm going to count the number of place values. 1, 2, 3, 4, 5, 6, 7, 8. I don't count the number of zeros. I count the number of place values that was moved. And this is going to be 8.1 times 10 to the negative 8 power. So now go ahead and press pause and try answering up to number 16 on your own. Okay, so please take a moment now to check your answers. And remember to be careful that you're counting the place values that the decimal was moved, not the number of zeros. Okay, now let's turn to page 4 and take a look at the exercises here. We're going to use what we've learned about scientific notation and what we already know about the exponent rules to rewrite these numbers. These numbers are not written correctly in scientific notation. The coefficients are either too big or too small. So we're going to rewrite these so that they're written correctly in scientific notation. For example, let's take a look at 17. It says 45.7 times 10 to the 8th. The 45.7 is far too big. It's supposed to be less than 10. Okay? The decimal is supposed to be after the 4. So what we're going to do is, for the moment, let's just ignore the 10 to the 8th and just focus on the 45.7. If this were the only number I had, and I had to write 45.7 in scientific notation, I would just write 4.57 times 10 to the first. 10 to the first because I had to move the decimal just one place value to put it right after the 4. Now I go back and I say, okay, well, the 10 to the 8th is also there, so I'm also going to multiply it by 10 to the 8th because that was also there. So now you know that when you multiply like bases, you can add the exponents. So now I can rewrite this as 4.57 times, you have 10 to the first times 10 to the 8th. When you multiply those, it becomes 10 to the 9th. When you multiply like bases, you add the exponents. So to review, what I do is I look at the coefficient, I just rewrite the coefficient as it should be. So this first part right here that I'm underlining in yellow is when I rewrote just the coefficient. And then the 10 to the 8th, you want to bring it along. So at the end, you just multiply by 10 to the 8th. So my correctly written number will be 4.57 times 10 to the 9th. That's how that number is correctly written in scientific notation. It's equal to the original number. Okay, let's try that again. Let's take a look at question number 18. In 18, we have 0.085 times 10 to the 5th. Again, the coefficient is too small. The number is supposed to be greater than or equal to 1. The decimal should go after the 8. So I'm just going to focus on the original coefficient, and I'm going to rewrite just that part. So instead of 0.08, I'm going to write 8.5 times 10. And I think to myself, okay, I would have to move the decimal place 2 places. And this is a number less than 1. So it's going to be 10 to the negative 2 power. Okay? Now that I've rewritten the coefficient, I'm just going to carry down my 10 to the 5th. That doesn't go anywhere. I still have times 10 to the 5th. So now I can rewrite my whole number by combining the powers of 10. So I have 8.5 times, well, when I multiply like bases, I add the exponents. So 10 raised to the negative 2 plus 5 is 3. So 10 raised to the 3rd power. And again, this number has to be the same as the original number. And it is. If I put both of these numbers in my calculator, or I rewrite them in standard form, I'll see that they'll both be equal to the same thing. If I write this in standard form, 10 to the 3rd, I'm going to move the decimal 3 places. 1, 2, 3. I'm going to get 8,500. Same thing up here. I have 0.085, but if I move the decimal 5 place values, 1, 2, 3, 4, 5, and I would put my zeros in, and here I would have also 8,500. So my new number written correctly in scientific notation is equivalent to the original, simply written in scientific notation. So now what I'd like you to do is press pause, and on your own, rewrite 19 through 22 correctly in scientific notation. Again, first focusing on the coefficient, just rewrite the coefficient, and then multiply by the other power of 10 that's there to get the new number written correctly. Go ahead and press pause now. Okay, now take a moment to check your answers. If you need to, please press pause. And notice how I showed my steps. So I showed my intermediate step that then brought me to the final answer. If you're not sure about any particular one of them, circle it and then make sure that you ask about it in class. Now we have the last 3 questions on our notes, 27, 28, and 29. Take a moment now to press pause, read through the questions carefully. Remember, with these problems, you want to read the problem over and over again a few times. First, just to get an idea of what is going on, and then to get some details from the problem. And then once you've tried all three, you can press play again to check your answers. So here are the answers for 27 and 28. 27 is 2 times 10 to the 4th. In 28, in order to find the difference, the USA has far more carbon emissions. I converted both numbers back to standard form and then subtracted. And then once I subtracted, I saw the difference was 10,000. And I put that back into scientific notation. But in class, we're going to learn how to subtract numbers while they're still in scientific notation, so you don't have to go back and forth. Now for number 29, I'm not going to put the answers here. We're going to talk about this one in class, but please be sure to write out your answer thoroughly. And this is the end of notes number 2. Thanks very much.